of AWS security, identity and access management, or IAM for short. Think of IAM as the security guard for your AWS house. Just like you wouldn't give everyone the keys to every room in your home, IAM helps you control who can access what in your AWS environment. We'll start with the basics and work our way up to complex real-world scenarios. By the end of this presentation, you'll understand how to secure your AWS resources like a pro. What is IAM? Let me break down IAM in simple terms. Imagine you're running a large office building with different departments, accounting, HR, engineering, and so on. IAM is like your building's security system. It decides who can enter which floors, who can access the copy machine, and who has the master key to everything. In AWS terms, IAM controls who can start servers, access databases, or even view your billing information. It's completely free to use, which is amazing considering how powerful it is. The key point here is that IAM follows the principle of least privilege. Give people only the minimum access they need to do their job, nothing more. IAM building blocks. Now let's talk about the main components of IAM. Think of these as the different types of security cards and access levels in our office building analogy. Users are individual people, like John from accounting or Sarah from engineering. Each person gets their own unique login credentials. Groups are like departments. Instead of giving permissions to each person individually, you can create a developers group and give all developers the same basic permissions. Roles are temporary passes. Imagine a consultant who needs temporary access to your building. That's what a role does. In AWS, policies are the rulebook that defines what each security card can and cannot do. They're written in a special language called JSON, but don't worry, we'll make it simple. Understanding IAM policies. Let's dive deeper into policies because they're the heart of IAM security. Think of a policy as a very detailed job description that spells out exactly what someone can do. For example, you might have a policy that says, you can read files from the marketing folder, but you cannot delete anything. In AWS terms, this translates to allowing getObject actions on specific S.3 buckets but denying deleteObject actions. The beauty of policies is that you write them once and can attach them to multiple users, groups, or roles. It's like creating a master key template that you can duplicate for different people. There are two main types: AWS managed policies, pre-made by Amazon, and customer managed policies, custom ones you create. We'll explore both. Policy structure deep dive. Now I want to show you what a policy actually looks like under the hood. Don't worry if this seems technical at first. I'll walk you through each part. Think of the JSON structure like a recipe. The version is like saying which cookbook you're using. The statement is the main ingredient list. It tells AWS exactly what actions are allowed or denied. The effect can be either allow or deny, which is pretty straightforward. Action specifies what can be done, like read a file or start a server. Resource tells us which specific AWS resources this rule applies to. The condition section is like saying only during business hours, or only from the office network. This adds extra security layers. What are IAM roles? Now let's talk about one of the most powerful features of IAM roles. This is where many people get confused, so let me use a real-world analogy. Imagine you're a hotel manager. Sometimes you need to let the cleaning staff into guest rooms, the maintenance team into utility areas, and delivery people into the loading dock. But you don't want to give everyone permanent keys to everything. Instead, you create temporary access cards that expire after a certain time. That's exactly what IAM roles do. They provide temporary, limited access to AWS resources. The magical part is that roles don't have permanent passwords. Instead, AWS automatically generates temporary credentials that expire, making them much more secure than traditional user accounts. How roles work. Let me explain the role assumption process, which sounds complicated but is actually quite elegant. Think of it like checking out a library book. You go to the librarian, AWS, show your library card, prove your identity, and request a specific book, assume a role. The librarian checks if you're allowed to borrow that book, and if so, gives it to you for a limited time. In AWS terms, when you assume a role, you're essentially saying, I need temporary permissions to do this specific task. AWS checks if you're allowed to use that role, and if so, gives you temporary credentials that expire automatically. This process happens behind the scenes and is incredibly secure because the credentials are constantly rotating. Types of IAM roles. There are several types of roles, each designed for different scenarios. Let me walk you through the most common ones you'll encounter. Service roles are like giving your AWS services their own employee badges. For example, when you create a Lambda function that needs to read from a database, you give it a service role with just the right permissions. Cross-account roles are fascinating. They're like having a guest pass system between different companies. You can allow users from account A to temporarily access resources in account B EC2. Instance roles are attached to your virtual servers, so applications running on them can access other AWS services without storing passwords in the code. Web identity roles let users authenticate through social media or corporate identity providers like Google or Microsoft. Real-world role example. Let me show you a practical example that many companies use. Imagine you have a web application that needs to store user photos in Amazon S3. The old insecure way would be to hardcode AWS access keys in your application code. But what if someone steals your code? They'd have permanent access to your S3 bucket. The modern secure approach is to create an IAM role that allows S3 access. Then attach this role to your EC2 instance. Now your application can access S3 without any hard-coded credentials. If someone steals your code, they get nothing useful because the permissions are tied to the server instance, not the code itself. This is why roles are considered a security best practice. Creating policies and roles. Now let's look at how you actually create these policies and roles. AWS provides both a visual interface and command line tools, so you can choose what works best for you. In the AWS console, there's a user-friendly policy generator that's like a form where you select what services and actions you want to allow. It then generates the JSON for you automatically. For command line lovers, the AWS CLI lets you create and manage everything through scripts. This is particularly useful when you need to create similar roles across multiple AWS accounts. I always recommend starting with the visual tools to understand the concepts, then moving to the CLI once you're comfortable. The CLI becomes essential when you're managing infrastructure as code. Let's compare policies versus roles. This is where people often get confused, so let me clarify the key differences. Think of policies as the rulebook and roles as temporary job assignments. A policy defines what actions are allowed, like can read files or can start servers. A role is a collection of policies that you can temporarily adopt. Policies are attached to users, groups, or roles. They don't exist independently. Roles, on the other hand, can be assumed by different entities at different times. Here's the key insight. Policies answer what can be done, while roles answer who can do it and when. You'll often use them together to create a complete security model. For example, you might create an S3 read-only policy and attach it to a data analyst role that your team members can assume when they need to analyze data. Let me share some hard-learned lessons about IAM security and best practices. These practices will save you from common pitfalls and security headaches. First, never use the root account for daily operations. It's like using the master key to your house for everything. It's too risky. Create individual IAM users instead. Always enable MFA or multi-factor authentication. It's like having a deadbolt in addition to your regular door lock. Even if someone steals your password, they still can't get in without your phone or authenticator device. Follow the principle of least privilege religiously. Start with no permissions and add only what's needed. It's easier to grant access later than to recover from a security breach. Regularly audit your permissions using AWS tools like Access Analyzer. Think of it as a security health checkup for your AWS environment. Common mistakes to avoid. Here are some common mistakes I often see, so you can avoid them completely. The biggest mistake is using wildcard permissions like action, asterisk. This is like giving someone keys to every room in your building. Way too much access. Always be specific about what actions you're allowing. Another common error is hard-coding access keys in application code. I've seen developers accidentally push these keys to public GitHub repositories, exposing their entire AWS account. Always use roles for applications. Many people also forget to set up proper monitoring. AWS CloudTrail logs every action taken in your account. Use it. It's like having security cameras that help you understand who did what and when. Finally, don't forget to clean up unused users and roles. They're like forgotten spare keys that could be misused. Let me walk you through a realistic scenario that combines everything we've learned. Imagine you're setting up access for a new developer named Alex joining your team. First, you'd create an IAM user for Alex with console access and MFA enabled. Then you'd add Alex to a developers group that has appropriate permissions for development resources. For the applications Alex will build, you'd create service roles with specific permissions, for example. One for Lambda functions, another for EC2, instances, and so on. This way, Alex's personal credentials are kept separate from the application credentials. You might also set up a cross-account role if Alex needs occasional access to the production environment. This role would require additional approval and have time-limited access. This layered approach gives Alex exactly the access needed while maintaining security boundaries. Summary and next steps. Congratulations, you now understand the fundamental concepts of AWS IAM. Let me summarize the key takeaways. IAM is your AWS security foundation. Policies define permissions, roles provide temporary access, and users represent individuals. Always follow the principle of least privilege and enable MFA everywhere. Remember that roles are generally more secure than users for applications because they provide temporary, rotating credentials. Use them whenever possible for EC2, instances, Lambda functions, and cross-account access. Your next steps should be to practice creating policies and roles in a test AWS account. Start simple, then gradually build more complex scenarios as you become comfortable. Most importantly, always test your permissions thoroughly before deploying to production. IAM mistakes can be costly, but with proper planning and testing, you can build a rock-solid security foundation for your AWS infrastructure.